All right, this video is going to go over how to graph rational functions. There are some how-to steps here for you to reference that we will use in order to sketch these graphs. So the first thing we want to find is the y-intercept. We are going to do that by plugging 0 into our function. So f of 0 would give me 2 times -3 in the top, 1 squared times -2 in the bottom. -6 over -2 gives me 3. So on my graph over here, I know I have to go through the point 0, 3. We're already in factored form, and then we want to see if there are any factors that are in common. There are none here. So let's look at the multiplicities of the x-intercepts to determine the behavior at those points. Now remember, any function is equal to 0, and if that's a rational function like this, then that means that the top is 0, and only the top. So I'm going to have two zeros, x equals -2, x equals 3. You know what? I'm going to actually do this a little bit better on my sketch with a scale. Like that. Okay? And these are both linear terms, so they're going to behave like lines at those places. All right, for factors in the denominator, note multiplicities of the zeros to determine local behavior. What that means is I have a factor in the bottom that is x plus 1 squared. That means it's going to behave like x squared, 1 over x squared, excuse me, at a vertical asymptote of x equals -1. And then x equals -2, +2 is going to be my other piece here. All right, compare the degrees of the numerator to the denominator. So in this case, I have an x squared leading term on the top. I have an x cubed leading term on the bottom. And so y equals 0 is my horizontal asymptote, like so. Next, we need to sketch our graph. Now, the one piece that I know for sure is I don't have any x-intercepts in this interval here, so I must go through and have something kind of like that. Also, I have to behave like the x squared function through this asymptote, so I bet my function goes like this, and I have to behave like 1 over x here, so I bet my function goes like this. Now, since I have these zeros, but they're not bounces, and I have this horizontal asymptote, I'm going to guess that my function does a little something like this, and use a graphing utility to check your work. But this is what our graph is going to look like. All right, let's look at another example. Here I want to write this function from the intercepts and the asymptotes. So I'm going to kind of go backwards in this case. And it looks very similar to the one I just did. But first, let's say, okay, I know that I need to have the point 0, -2 on my graph. I know I also need to have the points -2, 0, and 3, 0 on my graph. It looks like my end behavior on both sides, that there's a horizontal asymptote of y equals 0. Therefore, the numerator's degree must be smaller than the denominator's degree. And then it looks like I have two vertical asymptotes. X equals -1 and x equals 2. In this case, it looks like I have a 1 over x situation where they're on different sides here. However, over here, I have almost like an x squared, 1 over x squared situation for this vertical asymptote. All right, let's put this all together. So I know that y is going to be equal to, let's do our numerator first. X plus 2, x minus 3 would have to give me these zeros here. Also, I have vertical asymptotes at -1 and 2, and I know that has to be squared. And leaving it with these degrees means I'm good here. Now let's double check and see when I plug in 0, do I get -2? If I plug in 0 in the top, I would get -6. If I plug in 0 in the bottom, I get 4. So I get -3 over 2. What that tells me is I must have a 3 down here and a 4 up here. Let's see, if I multiply that by 4/3, will I get -2? 3's cancel, yes. 2's cancel, yes. Good. So then that has to be my coefficient in the front to make sure that I end up getting the correct y-intercept.